Yeah. Comes on everyone. Hope everyone tried the Disco problem. Yeah. Others, do keep your cams on. This was the last one that I gave you. I showed you how to do for a ring, and then I asked you to do for the disc as a homework. Did anyone try this? BQ by M, okay. QB by M, let's see. How to do this thing. Listen. Origin, did you get the answer for this problem? First, solve the problems now. You want everything else. Focus. I hope everyone has solved the questions. That is the most important thing. And I hope everyone started solving HCV right now or booklet, whatever you're doing. Start doing EMI. Don't take, don't wait for too long. We will wrap up this thing in today class and another 2 classes. We should be able to wrap up another 3 classes. Let's see how to do for the disk. Now listen carefully. The first part is the same. So till here it is the same thing. The electric field is R by 2 dB by dt. This guy will be 2 pi x and this will be x. So when you take the disk here at a distance x, consider a thin ring. The difference between the ring and the disk is at every distance x, you have a different electric field, and the charge is also different on each ring. So torque on each ring will be the distance x into force, the tangential force on the ring. And what is the tangential force? The electric field into the charge. The electric force into charge of the ring. This is x. The electric field is x by 2 dB by dt. The charge on the ring will be q, that's the total charge, by pi r square into area of this thin ring, which is 2 pi x dx. Please check the steps, everyone. Yeah, we did use something like this, in rotational mechanics when a disk is rotating on a rough surface. This is just torque on a ring. 2 will cancel, pi will cancel. You end up with q dB by r square x cube dx. But what you want is the torque on the disk. The torque on the disk will be integral torque on the ring. That will be q by r square into dB. Remember, you're integrating with x cube dx. This will go from 0 to capital R. This will be q dB r square by 4. The r square in the denominator will cancel out. And we know torque is nothing but dl by dt. This is q. There is a dt here also, I forgot that. Hmm. This will be dl by dt is equal to q r square by 4 dB by dt. Dt goes off. We get integral dl is equal to q r square by 4 integral dB. This is nothing but I omega, which is mr square by 2 omega is equal to q r square b by 4. Omega will be qb by 2m. Check. I think some of you didn't get the 2 ka part actually. Q by pi r square into 2 pi x is the charge per unit area. Yeah, right, Raghav. That's the thing. Q by pi r square is the charge per unit area. And this into 2 pi x, this will be the charge on the ring. Please look at the steps. Some of you got QB by M. I think the 2 was missing. Did I go up or I think this is right? Do check this out. This is a pretty good question, right? Anyone not clear with the steps, please ask me.
Sir, in the second step, you missed that dt, integral torque ring के बाद में. Hello.
Yeah. Don't know what happened. Let's see. Everyone clear with it?
Sir,
Sure, yeah.
sir, in the second step, q r by r square dv जहाँ पे आपने इंटीग्रल x क्यूब किया वहाँ पे dt नहीं लिखा.
Clear with the step? This would be a proper advanced question, right? This is what the kind of question they'll ask you. Clear? Next one. Now, this induced electric field which you're talking about, the story is actually not complete. There is something missing. Look at this. Induced electric field is non-conservative in nature. Do you guys remember what is a conservative force? Anyone?
वो
Del operator 0.
No. Tell something more decent. Right? That is like you're going too high level. Basic definition kya tha? That is a del operator is 0, but what is the basic condition?
r के
Anyone?
बराबर.
Work done is path independent. Work done by a conservative force is independent of the path. That is the basic definition of a conservative force. But in a closed loop, the work done will be 0. Clear? So now see what happens here. If you look at this conservative force, induced electric field, remember this is circular in nature. So because of this, what happens? Consider a charge q goes along the field in a circle. If we take charge q here, the force will be EQ. And if you observe here at every instant, EQ and the displacement are always parallel. The tangential force is always parallel to ds. Therefore, work done will be integral f bar dot ds will become integral EQ into ds. So this will be EQ into integral ds. Remember, you are adding all the arc lengths. This will be EQ into 2 pi r. But we know work done in a loop. The work done in a closed loop is not zero. Therefore, this is not conservative. This is a property of a conservative force normally. The work done in a loop is zero. So what is the problem with this? The problem here is, this will be mostly a theoretical question, everyone. Potential is not defined for non-conservative fields. Potential is defined only for conservative fields. This field is non-conservative in nature. So this is a direct question, like, and the field induced due to time varying magnetic field is what? It's a non-conservative. So let me show you what happens. So story is still there is something missing here. Clear? So what is the catch here? The catch here is we are actually being misled till now. It is like the recent Shah Rukh Khan movie. We think there's one Shah Rukh Khan, but there are two. So something similar happens here also. So that means this formula which we are using, integral E dot dl is d phi by dt. You can't write this equation actually. This guy can't be conservative. This has to be conservative. This has to be conservative field. Because this you define for potential difference. This has to be conservative field. And you're saying that E which we are getting is not non-conservative. It's suddenly non-conservative. So exactly what the hell is happening? This is the complete story. You have a time varying magnetic field. So when you take a conductor, and when you have this induced electric field, this is that E induced. The electrons present here, what will happen? The electrons will go opposite to the field. The electrons will start accumulating here. So these charges are induced. These are the induced charges because of the non-conservative field. And because of this, what will happen? These charges will not keep quiet. They will generate their own field inside. This field is electrostatic in nature. Because this is due to charges, no? This is conservative. There are actually two fields. These things will generate a force in the opposite direction. And in steady state, both of them will be equal. So the guy who is producing the electrostatic, potential difference is not the induced field, but the electrostatic field here. So this will be E induced plus E electrostatics will be 0. So why does it work so far? Luckily, because the magnitudes are equal. Since the magnitude is same, it doesn't matter. The answer comes out. You get the point? So if they ask you in the exam, integral E dot dl is d phi by dt, what is this E? This is the electrostatic field. This is not the induced electric field. You're getting the difference? So this is that electrostatic field. Like that. Mostly it's a theoretical question. Have a look at this. I'll just complete the whole story next time. You guys have to listen carefully, right? You can't ask like summarize, do that, do this. Which part you didn't understand? Meaning you're not focusing in the class. That's what happened. Don't daydream, na? Okay, it is night, na? Don't night dream. Focus. Listen to the class carefully. Which part you didn't understand, ask. Let me show you in the next page. I'll give it, I'll explain you in brief what happened. I know it can be a little confusing, but do focus. I know it's a dinner time. No, you finished eating already. Must be waiting for dessert. So what is the complete story? So listen. If you have a time varying field, I'll explain you this. You didn't understand. Let me explain you again. We have a time varying magnetic field. This guy created induced electric field, which is non-conservative. This cannot give potential difference because potential difference is defined for conservative fields. Now, this is always there. This is always there. If you put a metal, if you keep a metallic rod or metallic, anything, then the game will change. So if a conductor is placed, so if you keep a conductor in this region, like this case, I kept a conductor here. Because of this electric field, charges will start induced. We start getting induced charges. The electrons will go opposite to the field. So electrons which are present here, because of this field, remember electrons are negative charge. So they go opposite to the field. So all these electrons will start going here. So this area becomes negative and this area becomes positive. So you created charges. So we start getting induced charges. But remember, this will happen only if you keep a conductor. If you don't keep anything, there is nothing. Story gets over here. Story is over here. In order to see potential difference, you need to put a conductor. You start getting these induced charges. These induced charges will not keep quiet. They will create an electrostatic field, which is conservative in nature. Field due to charges is always conservative. This will create potential difference. And if the loop is completed, if the whole circuit is a complete loop, then you get current. So what Faraday saw time varying magnetic field and Faraday saw current. You're getting it? Faraday doesn't know all this story. Faraday has no clue what all this is. Completely experimental. Faraday just saw the time varying magnetic field is giving current. If you ask him, Faraday, why did you get that? He says, I have no clue. So this equation is actually integral minus E dot dl is d phi by dt. This electric field we are talking is actually the electrostatic field. But in steady state, means after here, look at this thing. After getting a lot of charges here, the green color field, the electrostatic field becomes so strong, this field will cancel this field. So you get a steady state. So in steady state, E electrostatic becomes equal to minus E induced. when I substitute that here, then it becomes E dot dl, which is induced, becomes equal to d phi by dt. You're able to do this because luckily the magnitudes are matching. You're getting, this is what we saw the final result as. Now look at the story here. Is the story completely clear what is happening?
So that's why it was not zero in first case, no?
Basically, that's when if you take E induced ka work done, that will never be zero.
Okay.
It is a non-conservative field.
Uh-huh.
The work done in a closed loop is zero for conservative fields. This is a complete story. That is actually what is happening. Have a look at this. I'm clear with this. Got it now. So the kind of question they'll ask in the exam is the induced electric field in EMI, right? E dot dl is d phi by dt. What is this E karke? So that E should be electrostatic field. That is not the induced electric field. And whenever you have an electric field which is circular in nature, these are non-conservative fields. Exam, there is a question like that. They said there is a field like this. There's a field like this. There was a field like this. They asked the question, which of the following fields are conservative or non-conservative? So the circular fields are non-conservative. Please check this out. All got this? Let's do one more question before going ahead. Can I turn the page? We have a magnetic field region. B is equal to B naught T. Now R is the radius. This is the top view. You took a rod like this, A, and this is B. This is O. So OA is R by 2 and AB is 2R. You're getting, the rod is perpendicular to this thing. So this AB is a conductor.
Sir, OA is in different.
Top view, Ray, what you're talking?
Okay.
O is the center, na?
Okay.
O is the center there. Is the diagram clear how it is? Is the top view? Meaning, it's like if you put your spoon on the glass, how does it look? If you have your glass and if you put a spoon like this, it extends outside, na? Able to visualize the diagram, everyone? Shaurya?
Yes,
So,
sir.
find VA minus VB. It's a good one. We'll do one thing. We'll make it a little simple. It is only till here, okay? Just touching here. We can do the 2R also. It will be nice, but I think if you got this idea, that you can handle on your own. Let's do till here. B is touching the corner. This is better. Let's do this thing. Find VA minus V. The previous one you can do, but okay. What I want to teach you is a concept. Let's get this thing. Find the potential difference across AB. anyone confused with the question, please ask. So there's a rod only from A to B. There is no loop, nothing is there. There is just rod there at rest. So you can't use motional EMF also BLV. Think how to do. I'll give you a minute or two. Any ideas? Let me help you. See, it's not a ring. Rod, this whole thing. This is a circular magnetic field region, no? We have a magnetic field which is B naught T for R less than R, and it is 0 outside. Remember one thing, people, you can find magnetic field only for circular magnetic field, cylindrical magnetic field regions. If you give me any other shape, I don't know what to do. You're getting it? That is the only shape we proved for, and that is the only thing that we have. Any other shape is not symmetrical. We can't find. Listen, I'm telling you what is happening here. So what we will do, we will complete the loop. Take a loop like this, OAB. And this is R by 2, and this is R. So this angle would be 60 degrees. So AB becomes automatically R root 3 by 2. So flux in the loop O, A, B, O is how much? B naught into T into area, that will be half into base into height. That would be B naught R square root 3 by 8 into time. So the EMF in the loop will be d phi by dt. I'll just get the magnitude from here, which is B naught R square root 3 by 8. And here flux is increasing. So we need to oppose it. So the direction would be out of the plane. So the current will be this way, anti-clockwise. Agreed? That means this entire loop OABO is acting like a battery. So can I write like this? So EMF in the loop is potential difference from O to B plus potential difference from B to A plus potential difference from A to O. Do you guys agree with this statement? The total potential difference in this loop OABA is nothing but OB plus AB plus AO. Please have a look at till here. I have to find for AB, but I can't find directly. So we are going little roundabout. But if you make a loop OAB, I can find. Is this clear, everyone? Raghav? Arushi? Anamai? Raina? Clear? Trisha? Radhe? Clear? Dania? Kavish? Anamai? No. This is where something interesting happens. See. So when you took this loop, B naught T, how is the electric field? The electric field forms circles, no? This is how the electric field is. Now you tell me if this is the electric field, and when you take this rod, from O to A, or when you take from the rod O to B, how is the electric field? Isn't the electric field perpendicular to this? Isn't it? The electric field is tangential, no? From here, if you look at the rod here, B, and if you look at the rod here, A, isn't this field always perpendicular? If the field is perpendicular to the length, what will happen? The field E bar is perpendicular to DL. What is the potential difference? E bar dot DL is the potential difference. Therefore, VAO, VOA, and VOB are 0. Is this making sense? Because the field is always tangential, you cannot have potential difference in OA and OB. Question ho gaya na? That means this term is 0, this term is 0. So VB minus VA is EMF in the loop, which is B naught R square root 3 by 8. Are you sure? To find the entire loop, and you'll always get these guys are 0. If you're passing through the center, it is always 0 because the field will be always perpendicular. So EMF in the loop is equal to EMF across AB. You're done. Since the field is perpendicular to the length, there is no potential difference. Or you can say like this thing, the field potential changes in the direction of field, and there is no field along the radial direction, no? So there's no potential difference. Since E is perpendicular to length, there is no potential difference. Please check the steps. It's a good one, right? It's not too difficult to solve, but you should have an idea. Kavish, got this? Dania, clear, na? Amu, got this? Reina? Kavya? Hasini, clear? Chirayu? Do have a look at this. Anyone not clear? Any step you're not convinced, please ask, get it cleared. There. So with this, we are done with induced electric field. The next one.
Sir,
Nanya.
sir, in the 2R1, OA and OB will be 0 also. Like-
Maybe OA will be 0. No? If you take here, isn't the field
Uh-huh.
outside also tangential? So OB will be like this, no? Then the field is still tangential, right? But then difference will be this. The area won't be so good. This is the 2R, no? Then you have to take which area? This area, isn't it? It won't be a beautiful triangle. Right, Daniel? It won't be a triangle. It will be a triangle plus a sector. So calculation will be a little bad, but the idea is the same story there. I hope you got the point. No? Clear? Next one. We have a small theoretical one, eddy currents. So, what are eddy currents? These are like unwanted currents. We don't these things just happen. We don't want them, but you always generate them. When a conductor is placed in a magnetic field, current loops are generated inside. Inside the conductor. This is one of the major problem, in all motors, dynamos, any electric motor you take, this is the problem there. Meaning what is happening now, when you have a coil here, right? And let's say if there is some kind of metal surrounding it, whenever current passes through this, you get this magnetic field lines. These magnetic field lines will pass through some kind of conductor, because see, whenever you make a motor, don't you make the entire part with metal, steel casing? So when this field lines pass through this metal, you induce potential differences. Meaning this will become like plus, this will become minus, this will become some minus and all. The currents will start flowing from here to here. So basically, in the casing of the motor, you are generating electricity. And because of this, what will happen? You start producing heats. You're getting it? So these currents are called eddy currents, and meaning it's an unwanted heat. You can check it out with this thing, if you switch on your fan and if you switch it off and if you go and touch the bottom base, can you see it becomes hot? Did you ever see the induction stuff? Anyone has an induction stove, electric stuff? It actually based on this only, eddy currents. This thing, right? This round thing, this will generate magnetic fields. So when you keep your vessel on top of it, the bottom of the vessel, you're inducing these eddy currents, which will make this entire bottom of the vessel hot. So basically, you're using eddy currents to cook food. You're getting it? So the induction stove which you use in the house is actually based on eddy currents. In steel factories, right, they use something called electric furnaces. They do the same thing. They put all the metal, iron ore and everything, and they generate magnetic fields. Eddy currents are produced inside, which will generate heat, and the whole metal starts getting heated up automatically. These currents are called eddy currents. So in day-to-day cases, right, they waste a lot of energy actually. Efficiency of the system drops because of this. You can't eliminate them, but you can decrease them a little. Let me show you how it looks. These are called eddy currents. And heat produced is called eddy heat losses. Just a theory there. This is how the currents are generated. They just form some random circular loops. So this is some unwanted current which you don't want. Did you guys ever, by any chance, broke a motor or something? This is electric cars and everything. You had small motors. Raghav must have broken multiple things. Right? So if you ever break a motor, in that you will observe the motor is not made of one steel block. For example, let's say you want to construct a steel cylinder like this. Getting it? No one will construct a solid metal block like this. This is a very bad idea. So instead of that, what they will do? They will make thin plates and they'll construct that way. The advantage of this thing is, this is how they'll construct it. This is how they'll manufacture it. They don't take a single block. They take this thin plates and they'll keep all of them together and make one big plate. The reason, look at here, what happened. The current is flowing like this. Can you see what happened? Current got restricted to small region. So by using thin sheets, the current will flow only within that sheet, so you can reduce eddy currents. So next time if you ever break a motor, you'll observe inside the motor it is made of plates like this. You won't find a single metal block, you'll find thin plates. So by constructing the systems with thin sheets, thin laminated sheets, you can reduce the eddy currents because currents will flow only in the thin sheet. You reduce the resistance between this thing, thin laminated sheets. So all motors are constructed like this. Now I know this really well because when I was in my third year, I did an internship in a company called Shakti Pumps, Coimbatore. Mein. So there they used to actually manufacture pumps and they used to export to Dubai. So there I saw how they construct the pumps. So when you make this pump, you have to make a cylinder first of all, so that you can keep the rotor inside. So when you make this cylinder, they don't make a solid one. They take thin strips. Like they'll take something like 2,000-3,000 of them and they stamp them. They put a bolt and they just compress them with a machine. That becomes one solid block type. And each sheet is laminated. So there is no current between sheet to sheet. So they hired 4 of us actually, 2 electrical and 2 mechanical engineers, and they wanted us to just a project idea, like how to increase the efficiency of the pump. 2 months ka project tha. No, they won't current flow. They said na laminated. So there's a plastic coating on top of them. So 2 months ka project. They gave us 9,000 rupees stipend per month. Free accommodation, free food. There is a hotel below the hotel. This thing, the rooms. You can go and eat how much ever you want. And every day we couldn't figure out much actually. We went there. It was pretty complex, meaning those motors are giving an efficiency of 31%. If you want to increase anything more than that, you have to change the materials. And whatever solutions we gave are not practical. Theoretical solutions we gave, but they don't work. It was fun. Every day we used to just go there and work for 3-4 hours. We used to just keep roaming in the factory everywhere. Big factory. It used to be fun. And he even gave us a Skoda car also as a driver. So wherever we want to, we used to roam on weekends. That get treated us very well. And then in the second month, right, they had a dealers meeting. All India ka, the salesmen, dealers, everyone came to Ooty. So they took us also for Ooty for 4 days. It was like all our friends were literally crying, "Arey yaar, tu ab to maza le raha karke." Some of my friends didn't even get any stipend also. You have to pay your own food and accommodation. So they are like, you're getting free food, free accommodation, free tour to Ooty. To Ooty we went for 3 days. Then he gave us the car and they took us to some tiger safari also. Hey, it was fun. Right? Though 2 months, Coimbatore tour, it was fun. So, and then he was asking us, like, will you guys be interested to work here? Then we asked him, sir, normally what is your salary package ka range? He said something X. Then I told them, sir, IITs may normally the starting package rate is 2.5x. It's difficult. Then he said, I understand. But that guy was damn rich. Right? He had a company and he had 2 colleges. He had 2 colleges of 11th and 12th in engineering. वहीं पे कुछ vacation नहीं होगा. Because we're students, he was treating us good. IIT students, so he thought like, देखते, can we hire them little cheap? End of the day, salary matters, na. He became quite fat, but he put on a lot of weight. Next thing, self-inductance. Third year, you have to go for an internship. So what is the self-inductance? Study well, I'm telling you seriously. When you go to a good college, right, you really have a lot of fun. Simple reason. The people who come there also worked hard, na? They'll actually value your hard work. But if you go to some Dabba college, right? For example, KJ Somaya, right? They'll call you and they'll say, we have selected you based on the merit. We have selected your name out of merit. I said, okay, great. You just have to pay 5 lakhs per year. You'll get a seat in KJ Somaya. I said, bloody, what kind of merit is this? BITS Pilani mein, the fees is like 4.5 lakhs per year for 4 years, and KJ Soma is asking for 5. I said, are you so great compared to this thing? And you know who all people get the call? People who didn't even do well in MHCT and all, they get the call. And these people ka ego gets inflated. They feel like, yaar, I'm a topper. मुझे कुछ पता नहीं था. KJ Soma people realized it. I said, bullshit topper hai yaar. They're charging you 5 like idiot. And imagine, even if you go to a college like that, now you tell me, people who come like that without any proper qualification, without hard work, why will they study there? They'll come there and chill out, na? You go and talk to them, Are, shall we do some project on AI? And shall we do something on computers? You know what they'll say? Are, movie जाते हैं क्या? Bowling के लिए जाते हैं ना? कौन करेगा project and all time waste? That is the big difference. So if you ask me, na, sir, why should we study hard and go to a good college? I keep telling you, it is to make good friends. You go to a good college, you'll make good friends. And good friends will make a hell lot of difference. Lot of difference. Remember I told you about that guy who got into Google? Do you guys remember that? Don't know. It's fine. It's not in the post. बाद में बात करते हैं. This guy, I'll tell you, listen. This guy got into Sony company. Getting it? During our placements, we had 535 students in our group. Literally, everyone got 3 to 4 jobs. 2010 ka baat tha ye. Normally, this is the scenario. 535 students. Imagine every student got 2 to 3 jobs. I had 6 teaching jobs. I was a teacher. I never got for placements. I was always a teacher. I started teaching in first year for part-time. Then by third year, I decided I'll become a teacher. So I was fine. I already had a lot of jobs in teaching. So this guy got into Sony company. 12 people got selected in Sony. It was a decent company. They went there. They worked there for 2 months. And this guy calls up and like, yeah, like it's a nonsense company. I said, what happened? Whatever work they're giving, even a 10th class student can do it. Then I said, why did they hire you guys? You know what he said? They're using us for marketing. Whenever a big investor comes, you know what he says? Look at this thing. We have 12 IITians working on your project. And Dada guy feels so happy. Oh, 12 IITians are working on a project. Le lo mera project. You're getting it? They're not teaching them any work, nothing. They're just using them like that. Matlab, IIT ka tag itna value hai. The other person gets impressed. You have 12 IITians working on my project. Awesome. And these people are pissed off. They said, yeah, you know, we are not interested in money in the first 2 years. We want to learn something. Money aayega baad mein when I have skills. Within 4 months, all left the job. Now see, look at the guts, huh? You got a company placement from this thing and you say like, yeah, I can find a better job anywhere. Ye confidence kahan se aayega? This confidence comes because, you know, you have worked hard for something and, you know, you can again work hard for something else. The people who don't leave the company now, who are scared, like, yeah, dusra job milega, nahi milega. These people who are like ruthless, like, yeah, I can get a bloody job anywhere. I don't want to work in a hopeless company. So this guy was working in Sony, but one guy was more smart. So this guy, now one of his friend, his name is, this guy was Saikant, the guy who gave the job actually. So this guy was working in Amazon. So this guy who was working in Sony started applying for Amazon. And the Amazon guy started rejecting the resume. They said like, yeah, you're in Sony. Amazon is a service product company. Your profile doesn't suit us. We don't want you. His resume was getting rejected literally. Even if you're from IIT, they don't care. And then this guy, you know, called up one of his friend there and said, "Yaar, मैं apply कर रहा हूँ and these people are rejecting." I said, "यार, तू मुझे resume भेजो, मैं देखता हूँ." Now what happens, right? When a company का employee refers, they look at the resume. You're getting it? Company का referral letters. So this guy forwarded the resume on his name and saying, you know, this guy is my friend. I'm sure he will do well. Please at least call him for an interview. So interview they assigned after a month and this guy trained him. I said, yaar, you know, देखो ये ऐसा concepts main पूछेंगे, ये learn this thing. Now see, this is what friends do. They'll actually help you to grow. Friend matlab not someone who will अरे movie जाते हैं चलो आज class bunk करते. This is not friendship. That guy gave him a chance for opportunity. That guy told him, you know, what all to study and all. 1 month time was there. Now it is your job to work hard. This guy learned well, did everything, went for the company interview, got selected. He got a job in Amazon. Getting it? He worked in Amazon for 2 years. Then he applied a resume to Google. Now, how did he apply? I'm an employee from Amazon. He never said I'm from Sony. Then Google said, okay, Amazon employee must be hardworking. Let's call him for interview. He went there. He got selected. Google Hyderabad. He worked for 3 years. Every Sunday, we used to go to Google with him. We used to eat food. It is free. After second week, they kicked us out. So it was fun. Literally, every 300, 200 meters, there is a food counter. But itna food hai, matla full campus is like, there are at least 5 to 6 canteens, you have all kind of foods. Right? Can you imagine there are like 12 to 15 desserts? Super food tha. Literally used to have everything. Google. I heard it is still the same way. One of your senior who went to Google was saying, sorry, itna food milta hai. I'm scared I'll become fat. It was fun. So third year ho gaya. Then he worked hard. He little applied for everything. He went to US for Google ka main campus he shifted. Now you just tell me, this guy was fine, working hard and everything, but how did he get an opportunity? Because you have a friend who is working in Amazon. This is not the only story. I can tell you a lot like this. I had one of my friend who was working in, a civil construction company, civil engineer. Tha. This guy was not liking it. He was pissed off. He wanted to get into marketing. But because of his civil engineering profile, no one was looking him in marketing. So we are talking in a group one time. Then he was saying, "Arey yaar, mujhe marketing kuch karna hai. मैं क्या करूं करके." And then I remembered one of my junior. We used to call him C-Tech. उसका actual नाम भी पता नहीं मुझे. But IIT में इसका nickname was C-Tech. I don't even remember why the bloody we used to call him that. कुछ तो किया था ये weird. तो उसका नाम C-Tech बन गया था. I said यार C-Tech से मिलना वो देख लेगा कर. Now we don't know C-Tech was that rich. Huh? In college तो we didn't know C-Tech was that rich. C-Tech was a damn rich guy. His dad had a something like 2-3,000 CR का company. It's a big company. And this guy after passing out from IIT कुछ MBA किया. He became the head CEO बन गया था वहीं पे. So this guy contacted them and said, "Yeah, C-Tech, I'm like this करके अरुण ने refer किया." Said, "Oh, अरुण ने refer किया." Like he called up. He's like, "Sir, आपने किसी का reference भेजा था." You're getting it? Senior था. Now see, if you remember, na IIT में literally we used to roam around with t-shirts and shorts with this guy. We never knew he was so rich, and he never bothered to tell us he was that rich. 10 rupees Frankie के लिए we used to fight sometimes. ऐसा होता था. 1 Frankie we used to share. It was weird. मतलब वही बोल रहा हूँ ना, people don't care like how rich you are and all because you worked hard and you came there. Everyone values your merit. सबको पता है. No matter how rich you are, you don't get into IIT without working hard. Now that guy said, "Okay, I will consider करके." And this guy went with a resume. I told him, "Yeah, boss, तू देखो वो is it worth it to take him? Don't take on my recommendation." So that guy went there. He said, "Okay, fine, हम कुछ करेंगे करके." He said, "1 year you work with me in marketing division, and after 1 year I'll give you recommendation saying this guy is very good in marketing. उसके बाद जो करना है आप कर लो." This guy worked in that company for 1.5 years, and then he applied for ITC, and then he became a manager बन गया था ITC में in managing division. Why did this all happen? Because you had a friend who is ready to help you. Then you got an opportunity. So again, I'm telling you, put a fight. Trust me, last 6-7 months you can turn around this thing. At least IITs, BITS, NITs, IIITs. This is what you're looking at. Don't give up now. Continue working. I'm telling you, really get pretty good friends. So you'll get crazy friends. You go to this normal Dabba college now, you'll get stuck with idiots. Who knows only time pass in life. Don't do that. You guys are much better than that. Let's see. The opposition to change and flux. In a system created by so look at this thing, the opposition to the change in flux in a system created by itself. Statement looks weird. You know what it is saying? The system is generating flux and for some reason it is fighting with itself. I'll show you how that works. Because any system doesn't like change in flux. Remember I told you, we don't have a problem with flux, we have a problem with change in flux. You know, how is this like? Your right hand is beating you and your left hand is trying to stop it. Kabhi suna? There's something called alien hand syndrome. One of the hand is completely out of your control. It does whatever it wants. It doesn't listen to you. It behaves like it's an independent person. There's one guy who had a problem like this. It was a documented thing. That hand likes to steal stuff. You go to a restaurant, it takes spoons and keeps in the pocket. It does whatever, and the worst part, you don't even realize what the hand is doing. It's called alien hand syndrome. You can search later on, you'll find out. Pretty interesting thing. So I know you guys will feel wish I had one. It can do the homework on its own. Na? इतना अच्छा alien है नहीं मिलेगा. So what is exactly happening here? Imagine you have a solenoid. Let's say this is coil 1, coil 2, coil 3, and so on. So when the current starts flowing in the coils, what will happen? You start getting magnetic field lines. Now see what happens. The magnetic field due to the first coil will enter the other coils. Now other coils don't know who is coil 1. They will simply say, okay, initially I didn't have magnetic field, and this coil 1 is suddenly sending magnetic field lines to me, and I don't like this. I don't want the change in flux. So because of this change in flux, these coils will oppose the change in flux. So you're getting, so one part of the coil is generating flux, which is passing through the other coils, and the other coils don't like. Similar thing happens with other coils. So the magnetic field generated by the second coil will pass through the other coils. They don't like this. And this will keep on happening. Are you getting what do you mean by self-inductance? You oppose yourself. One part of the system is creating flux and the other part doesn't like it. So this flux is proportional to the current. The proportionality constant is given by Li. So what is the meaning of this L? L is self-inductance. So the physical significance is higher the L, more difficult to change the flux. It's like resistance to changing flux. Higher the L, more opposition to change in flux. So if there are two systems, one is small L and one is 100 L. The 101 L is more difficult to change the flux. Have a look at this. That's the basic definition of self-inductance. Others, you need to keep your cams on. Chirayu, Dania, Divanshu. This December end, right? There is a IIT Bombay ka Tech Fest hoga. Make sure to go. It's one day. You can treat it like a picnic and go. It is worth it. You will at least get to see like how it is. And if you have already gone, go again. It's pretty nice place. You should definitely go. I'll tell you when the dates come out. Have a look at that. That's how a premier college looks. Mumbai may have Dabba colleges. They have a 10 floor, 6 floor, 7 floor building and they call it a college. Go to Bombay and see. You'll have like what IIT Bombay is 350 acres. That is pretty small. IIT Madras is 670. My college. IIT Kharagpur is 2000. IIT Guwahati is 1000. Delhi is also small, 300. But remember, Delhi is in middle of the city. Yeah? Bombay, middle of the city, 300 acres is not a joke. Clear? Now, so once you got the self-inductance, any doubts on this page? Can I turn it? So flux is equal to Li. From Faraday's law, we know EMF is d phi by dt. Now listen carefully here. This is something most people ignore this. This is minus d Li by dt. This is minus L di by dt. Minus I dl by dt. Chain product rule. Everyone writes E is equal to L di by dt, but there's a catch. Be careful. If L is constant, this is just like F is equal to dp by dt. Newton's second law. The current yeah, right, Raghav. That's what you're saying. If L is constant, then the EMF becomes minus L d by dt. This quantity what we call as back EMF. This E here is called back EMF. What do you mean by back EMF? Basically, whenever you have an inductor, this is the symbol for inductor. It looks like a spring. So an inductor having current I can be treated like a battery of LdA by dt. So you can replace the inductor with a battery with LdA by dt. This is called back EMF. Again, understand, inductor has no problem with current. It has a problem with change in current. So if you have a current I like this, and if I is increasing, inductor doesn't like this, it will try to generate a battery in the opposite direction. If suppose I is decreasing, again, like I'm saying, it has no problem with current. It has a problem with change. So if the current increases, I will try to oppose. If current is decreasing, I will try to support. This time battery will be like this. Have a look at this. So there is a second formula. So first formula is flux is equal to Li. Second formula is E is minus LdI by dt. Check it out.
So can you show the previous? Yes, sir.
Clear? You can put on the thing in the red box. Next one. Let's see this thing. So just like capacitor, right, which stores energy in the form of electric field, we take self-inductance is also something like capacitance only. Self-inductance of a solenoid. So if you have a solenoid, length L, R radius, and N is the number of turns per unit length. And let the current be I. So the flux in the solenoid will be total number of turns into magnetic field into area. What is the total number of turns? N into small l. What is the magnetic field? Mu naught into Ni. What is the area? Pi r square. I hope you remember the solenoid car result. Should remember the results. The magnetic field B is given by mu naught Ni, where small n is the number of turns per unit length. So we get flux is equal to mu naught N square pi r square L into I. And we also know flux is equal to Li. I will cancel. We get L is equal to mu naught N square pi r square L. Everyone should mug up this result. Straightforward question of bits and CET. CET में direct they ask which are the formulas for self-inductance of solenoid. So inside the solenoid, let's say if someone introduce a metallic rod or something, let's say we keep an iron rod. Mu of iron is 4,000 times mu naught. So this is called mu relative. This value is 4,000. So if you keep a rod or something here, self-inductance formula becomes L is equal to mu medium N square pi r square L. where mu medium is mu relative into mu naught. Just like capacitance, the self-inductance depends on the dimensions and depends on the medium. Check this out. Clear, everyone? Put it on. Let's do 1-2 questions before going ahead with more theory. Yeah, let's see a question. Can I turn the page? All clear so far, everyone? Reina, clear? Divanshu, Shaurya, Kavya, Divanshu, clear? Let's do a few questions. There's a little more theory, but too much theory, you get bored. Let's do 1 or 2 problems, we'll go back then. So we got a solenoid. We have done this before of radius r. Someone took this thing and they rewounded this.
Ry.
Rewounded to half the radius. Previously, we have done this for magnetic moment and magnetic field. Find the ratio of self-inductance before and after. Let's get this thing. So you took a solenoid, it's a long solenoid, and you opened the entire wire and you again wounded it to half the radius, smaller coils. Find the ratio of self-inductance before and after. This is the formula for self-inductance. Write it down in case you didn't. Mu naught small n square pi r square L. L is the small l is the length and r is the radius, and small n is the number of turns per unit length. Try, you got a minute. Easy one.
Two is to one.
Okay. 2:1, right? Others, try. I'll give another 1 minute. Let's see. So what is the formula there? L is equal to mu naught. Now, remember I told you last time, whenever you rewound the coil, what does not change?
Length.
Nah.
Total length.
Nah.
Number of
Number of
turns per unit length.
turns.
Number of turns per
Unit
unit length. So let's say if this thing has n turns, This will have 2 n turns. Number of turns will change. Number of turns per length won't change, but the length becomes double, na? The number of turns per unit length remains same. That will depend only on the width of the wire. So self-inductance will be L1 mu naught n square pi r square L by L2 mu naught n square pi r becomes r by 2 whole square and L becomes 2L. 2:1. Easy? Check it out. Clear, everyone? Next one. Any doubts on this, please ask. Next one is a good one. We have a solenoid, length L, radius R, and the current I is equal to T, where T is time. So current is continuously increasing. At the same time, someone took a iron rod where mu m is mu r into mu naught. The rod is going with velocity v. This is the scenario at t0. Then iron rod enters the solenoid. This should be a pretty good one, right? I think easy to solve, but most people don't understand what the hell is happening. Is entering the solenoid with constant speed v. At t0. Find EMF across the inductor. Find potential difference across the inductor. So we have a solenoid of length L, radius R. Current is changing with time. At the same time, the rod is also entering the solenoid from the other end. You have to use this formula, the one in the red box. When the rod enters, what happens? Isn't L also changing? L is also changing. So you can't use this formula here. This formula is valid only when L is constant. Most people will use this formula and they mess up the answer. Try. I'll give you a minute or two. It's a good one. Yeah, don't worry about all that rather. They're just talking about potential difference. No, that's a different story. That won't affect L actually. Try everyone. Find the potential difference across the solenoid inductor. Anyone is not clear with the question, please ask me. Any ideas?
चेंज इन लेंथ को v डालना है.
See, we will divide the whole thing into two parts. Let the rod enter somewhat like this by x. Then this will be L minus x. So you can treat this as two parts. So the self-inductance will be mu naught n square pi r square. Length of the piece will be L minus x plus this will be mu medium n square pi r square. Length is x. Agreed? Yeah, it's an infinite meaning. See, Raghav, whenever someone says a long solenoid, the meaning is L is much greater than R. The length of the solenoid is much greater than radius, so we can almost treat it like infinity. Because in practically, there's nothing called infinite. And what is x equal to here? X is equal to Vt, na? Velocity into time. You're done. So what is EMF? Minus L di by dt minus I dl by dt. I know I is equal to time. I know L ka value, substitute and differentiate, you'll get the answer. Clear? So you will get the EMF as function of time t. Check out the steps. You can just differentiate dl by dt and you'll get the answer there. I will use the differentiation to you. Dx by dt is V. And di by dt is 1. Because I is equal to t. Please check the steps. It's a pretty good one. Simple question to solve, but most people don't realize this formula. If you see in the books also, they let E is equal to minus L d by dt. That is because L does not change most of the time. So it is like in school, you used to write F is equal to ma. Works most of the time. But problem when mass changes, you can't use the formula. Clear with this? Can I go ahead? Next one. Let's do an easy one. You have a solenoid and you have a battery. That's it. Only solenoid and battery. So when the switch is closed, find the current in the solenoid as function of time t. Straightforward question. If you connect a solenoid to a battery, you know what happens when you connect a capacitor, Q is equal to CV. You know what happens when you connect a resistor, I is equal to V by R. What happens when you connect an inductor? So just like capacitor, resistor, inductor is also an element. So you get everything, LR circuits, RC circuits, you'll have everything with L. Try everyone. What happens if you connect an inductor to a battery? Help you? Easy one. See,
So
you get it actually in a very small step. Let the current be I. This is L. This is V. Remember, you can use Kirchhoff's law. V minus L di by dt. Remember, this guy will act like a battery, back EMF, which is L di by dt. We're not going to write like this later on. You can directly write V minus L di by dt. So V minus L di by dt is equal to 0. So this will be V by L dt is equal to di. Integrate on both sides. I is equal to Vt by L. The current will keep on increasing forever. Straightforward. The current will never stop. It will just keep on increasing. Clear? Let's do something better. This is an easy one. All got this. So in case of a capacitor, current becomes 0. Charge is constant. In case of a resistor, you get a constant current. In case of an inductor, you get an increasing current. We have an inductor. We have two smooth rails. Do you guys remember this question? We have done this with resistor and capacitor. System is trying to oppose Raghav, but it can't do anything. It will just keep on absorbing more and more. So gravity is there. Mass of the rod is m. Length is L. Magnetic field B is constant. These are smooth conducting rails. Initially, when you're starting, x is equal to 0. Initially at rest. So the question is, describe the motion of the rod. That is an important one. How does this rod move? Describe the motion of the rod. And the position of the rod as function of time t. Initially, it said x is equal to 0. Let's get this thing. This will be a proper advanced question. This will be a paragraph. Think how will you do this thing? You have a lot of things here. Motional EMF, because the rod is going with velocity, you get a BLV EMF. Because of EMF, you get a current. Because of current, you get an ILV force. This question is quite similar to this guy. If you remember, we had done this 14th one. 14th, we had a resistor, we had a capacitor. Now we have an inductor. Try 2-3 minutes. Then I'll show you how to handle this. Anyone figure out what kind of motion you get?
Sir, 1 minute.
Yeah. Try. Take a minute or two. People, the next week a test is online, huh? It'll be there till next Friday, so do make sure to give it. I'm giving you more time. Portion is same, magnetic force and magnetic effects of current, but it's an advanced paper this time.
Sir, on website was showing it is expired.
Yeah.
Yes.
Shauri is fast. The moment I told you already checked.
No, sir,
No.
I checked for like previous test.
एक मिनट देख लेता हूँ. Deadline नहीं डाला. Yeah, it's there now. Yeah, this is there now. And that additional papers, remember, which I gave, I'm extending those timeline for 1 more week, so you can write. So there are 2 more extra practice papers which are there. One is like I kept one old topic and this thing.
Laws of.
Yeah, laws of motion capacitor. One is kinematics and current electricity. So people who want to do some little extra practice, you can write those papers. They won't be graded. It's only for your practice. How do we do this?
Sir, जैसा वो किया था वैसे
Start like this, na? Always start like this. Let the velocity be v. Listen carefully. Get a pretty good answer. And you will see why this will be an advanced level question. So after some time, let the velocity of the rod be v. So if this guy is going with v, this will act like a battery, like this EMF BLV. So the circuit will become BLV minus LDI by dt is equal to 0. So from here we get di by dt is equal to BLV by capital L. Getting that from Kirchhoff's law. Second thing, if you draw the FBD of the rod, the forces acting on the rod are mg, the magnetic force ILB. So whenever a current carrying rod goes through magnetic field, there's a magnetic force and acceleration. So we get mg minus ILB is equal to m into a. Differentiate on both sides. Differentiate with respect to time. mg will be 0. This will be LB di by dt. This guy will be m dA by dt. But remember, acceleration is dV by dt. What is di by dt? That will be b square L square v by capital L will be, if you bring mass this side, this becomes d square v by dt square. Can you see something here? I'll show you the next spreadsheet. So we got d square v by dt square is equal to minus b square L square by m capital L into v. What is this looking like? SHM equation, na? This looks like SHM. The rod is actually executing SHM. So this term here is your omega square. So omega is root over b square L square by ml. So the equation will be v is equal to v naught sine omega t plus phi. The velocity is a sine function. Have a look at this page. The main idea is, so the rod is describing an SHM. So unlike that, when you had a resistor, it was an exponential decay function. It was like viscous force. When you had a capacitor, it is going with constant acceleration. When you keep an inductor, it is oscillating like SHM. Do look at the steps here. So one is Kirchhoff's loop law. This is Kirchhoff's law, and this is the FBD of the rod. Please look at the steps. Any line that you didn't understand, yeah, please ask. Go through it step by step.
Sir, here we can't substitute I as Vt by L.
I is equal to
Vt by L.
dt by L. Are V is variable, na God? How will you integrate V? Na?
Okay.
That v won't come out of the integral. Na?
Acha, okay.
Yeah. Clear? Turning the page. So this is the equation. V is equal to V naught sine omega t plus phi. Job is still not over. You need to find that V naught and phi. At t0, velocity is 0. So this will be V naught sine omega t is 0 sine phi. So therefore phi also should be 0. So V naught is equal to V naught sine omega t. Great. Omega I know, I need to find V naught. Now understand the situation. At t0, current was 0 in the circuit. So the rod mg, ILB and acceleration which you had, mg minus ILB is ma. This term was 0. So at t0, acceleration was g. Okay. So from this equation, what is acceleration? dv by dt, which is v naught omega cos omega t. So at t0, acceleration is v naught omega cos omega t is g. So this will be v naught omega cos 0 is g. So v naught is g by omega, because that is how you find the constant. From here, we got velocity v is equal to, I'll turn back, g by omega cos omega t sin omega t. This is the velocity as function of time t. How will you find position? Again, integrate dx by dt. G by omega sin omega t. So this will be dx g by omega integral sin omega dt 0 to t 0 to x. We get x is equal to g by omega square minus cos omega t. Limits will go from 0 to t. We end up with x is equal to g by omega square 1 minus cos omega t. Cos 0 is not 0. That's your position as function of time t. You know what is the meaning of this? The rod is actually oscillating like this. So the rod initially is here. This is x is equal to 0. The rod is going somewhere till here. X is equal to g by omega square. This is your mean position. The rod doesn't stop there. It will continue to go here. That will be 2g by omega square. So the initial position is extreme. This is another extreme. So the rod is oscillating between these two positions. And this is the mean position. And this distance is your amplitude. They can ask a lot of questions in the exam. Find the amplitude of the rod. Find the maximum distance it will travel downward. Find the velocity as function of time t. Find the position as function of time t. Find time period of oscillation. I can ask you everything related to SSL. Please look at the steps. Again, listen, the whole thing I'll explain. First thing, let the velocity be v. The rod will act like a battery, BLV. So this whole circuit will look like this. We have an inductor and we have a battery. Battery ka EMF is BLV, inductor is L, current is I. Kirchhoff's loop law, BLV minus LdA by dt is 0. From there I got dA by dt. Next thing I draw FBD, mg minus ILB, which is the magnetic force. I hope everyone knows the direction. If you have a rod like this carrying current I and magnetic field B is this way, IL cross B force. F magnetic is IL cross B bar. The force will be upward. So the ILB is actually slowing you down. So mg minus ILB is equal to ma. Differentiate on both sides. Mg ka differential 0. ILB will become dA by dt. A becomes dA by dt. Substitute this dA by dt in this. From there I got d square v by dt square is minus b square L square ml by v. This looks like SHM. The solution for this differential equation is v is equal to v naught sine omega t plus phi. Now here, this is a variable. Phi is also variable. If I can find these two, my job is done. At t0, velocity is 0, so phi is 0. Differentiate this, I get acceleration. At t0, since the current is 0, the only force acting on the rod is mg. So A should be equal to g. So at tg, acceleration should be equal to g. From there, I got v naught ka value. Once I got v ka value, I integrated it. I got x ka value. After it just becomes a max problem after this. Please look at the steps. First page. Any doubts on this page, please ask. Raghav, got this? This would be a pretty good paragraph. I can ask you multiple things. I would ask you like find the time period of oscillation and find the maximum distance it goes down. Check this out. It's a matrix matching. You can ask even more. Look at this page. Literally, it was an SHM actually.
So but in SHM it is minus omega square x now, but either to VI.
So you have a VI, but no difference now.
Okay.
See, Max doesn't care, na. You're calling it V. Max calls it X. Max will say, I don't care what number you're calling it. The differential solution is same. It looks like SHM. But before SHM, it is actually a mathematical equation, isn't it? All clear with this page? Any doubts on this page? Raghav, it's a differential equation ka solution. Like I said, it's a mathematical thing. If that thing was X, we call it SHM, simple harmonic motion. Simple harmonic meaning it's a function which is a sine or cos function. Look at this page. Do ask me if you're confused. Any step you're not clear. Yeah. Can I go ahead? Last thing, we have a bit of a theme. We'll finish off with that. So if there's a field and everything, there's also an energy stored. So if you have an inductor L and if the current is I, you can treat this like a battery and EMF is LdA by dt. We know power is nothing but, so here the power is being absorbed because the current is going into the battery, which is voltage into current. So here the I into LdA by dt. So if you take power into dt, integral, this will become integral Li di. Power into dt is energy stored. This will be half Li square. Can you see the resemblance? It looks like half CV square. So the energy stored in inductor is given by half Li square. And we know from solenoid, half Li square, I can write L ka thing as mu naught N square pi R square L into I square. We can adjust this a bit, 1 by 2 mu naught Ni whole square into pi R square L. What is pi R square L? Volume. So we get the term energy by volume. Anyone remembers what is energy by volume called?
Energy density.
Energy density.
Energy density. And do you guys remember the formula there?
Half E naught.
Half
E
epsilon square.
Oh.
यहाँ पे it will be 1 by 2 mu naught B square. This we have done in capacitors. If you go back to capacitors,
So self energy का
this is how we derive this energy density, half epsilon E square. The energy per unit volume in the form of electric field is half epsilon E square. Same formula here, the only difference is 1 by 2 mu naught V square. This is called magnetic energy density. That means magnetic field is nothing but another form of energy. Remember this thing, all field lines are nothing but another form of energy. This is magnetic field energy, magnetic energy density. That is energy per unit volume. So if you remember the formula, it is half epsilon, here it is 1 by 2 mu naught, then it is E square, this is B square. So energy is stored in the form of magnetic field lines. Check this out. Clear? So with that will wrap up for the day. So make sure to revise all this stuff. We'll catch up tomorrow at 9 o'clock, same time. We'll continue from here. We will do something called LR circuits. Do you remember RC circuits? You should just go back and revise this once. If you remember in RC circuits how we solved, I hope you remember this method. Do you guys remember this general method? I'm going to teach you anyway tomorrow, but do you guys remember this general solution?
yes.
The charge on a capacitor is given by A plus B e power minus t by tau. Without integration, you can solve problems. This was a general method I taught you there. Do check it out and come. We're going to do that anyway. So same thing we have here, something called LR circuits. So we did RC na, before. We will do LR. We'll also do LC. So all combinations of R, L, and C. So that will be the main thing tomorrow. And then by Wednesday, we will wrap up the chapter mostly. So you should be able to handle around the first 55 questions of HCV if you're doing HCV. Right, maximum things are there. So start working on this. Don't delay now, because if you finish all the chapter on Wednesday, Saturday maybe thoda spill over, and we will start AC on Saturday or Sunday. That means you'll have like barely time till next Wednesday. So that's like 8 to 9 days. Again, I'm telling you, the current chapters, do them properly. Think of like this, okay? You have started your revision for JE and you are revising for electromagnetic induction. Because these chapters, you won't get time for revision again. So these chapters, you have to do them properly. And remember, electromagnetic induction AC is like as good as rotational mechanics. If you see this chapter, every damn thing is there. Resistor, capacitor, rotational mechanics, ILB force, viscous force, everything is there. You can see a lot of things happening, electric field, everything was there. So do this chapter properly. All the current chapters do this properly. AC will not take much time. AC will get over in 4 to 5 classes, and then modern physics will take maybe around 6 to 7. Modern physics is easy, but there are little different varieties. Mostly by October end, we will finish all the main advanced ka portion. We'll finish off even some mains ka topics also. And after Diwali, it is like I will be leaving some chapters which are all ratta marne. We have to mug up the formulas. That we can do together in the class. Like, I don't trust you guys will my head anyway, so I have to do it in the class. I did that once and I regretted that. 2019 ka batch. I said, yeah, all these formulas. I wrote all the formulas from the book and they said, read. They said, okay, sir, okay, sir. And that idiot that year, 2 people lost, seat in where JEE mains because of that. They got 2 hopeless questions which are sirf ratta mar ke jayega, so you'll get 8 marks, 4 plus 4. And these people got disqualified because of just 2 questions and 1 question. That year we felt really bad. I know they could have done other questions, but you just remember they would have got an answer. That's why I like to call it inorganic physics. You just have to by heart. Okay, so that you will work it out. That's not a problem. So once I think October end gets over, we can start off a revision. We can have like, one class I'll teach the JEE mains ka topics, one class we can keep on revising some old topics. We'll do something of that sort. Okay, so we have done almost like the last problem is pretty good one, 24 problems. So make sure to resolve everything. You're doing HCV, start doing first 55 problems. Or if you're doing your booklet, whatever you're doing, start solving EMI. Don't wait now. The next week test is online till Friday, so make sure to give. Okay, I'll see you guys tomorrow at 9 o'clock. So those who are out, stay back. Others are free to leave. So take care, stay safe. I'll see you tomorrow at 9.